question number 5 of October, November 2025. In this, we have been given a function f of x, where f of x and g of x are polynomials, so that x minus a is a factor of prime f of x. So let's take first as if we have function prime or this one, that could be a factor of, as it's given in the statement, x this square, and it would turn out to be with g of x plus the same factor 2 x minus a with g of x. So the factor can be taken out because as it's given it is a factor, so we can take the common as x minus a in this, and the other will be remaining as g of x. So this would just be x minus a, and we know that this is just equal to f of x, or we can say that this value is x. So x of and this will be f x, and then will be I did not multiply that, because that will be multiplied with both g of x times x, and a will also multiply with g prime of x, and you'll be left with g of x. So we can say that it's a factor of, and this proves us it's a factor of this. It was a 2-mark question. It was easy. So for the next is, it's given that the polynomial, the factor of this. So we need to find the values of p and q. So let's write it. Px plus q. This must be equal to the given factor, means okay, and it is given that the factor of this, and previous value for instead of a we have square now. So let's just assuming that, let's say we had f of x equals x minus a keeping above thing, f of x equals to x minus a whole square, Instead of this a, we have this 3. So we can say that if that was the factor of g of x, so we can say that this whole thing can also have a factor of f prime. So the similar way we can write that x minus 3 will be a factor of the same thing like we have, because previously we have just found that f prime would be just like this if you multiply the factors. So we can say that we would have 6x squared minus 8x plus p would be equal to f prime x. So if we have the value of function as 3, so let's plug it in this. So instead of x, we would just plug in the value for 3. So we would just have p equals to 0, and you would have 54 minus 24 plus p equals to 0. This would give us the value for p as minus 54 plus 24. So p would be just equal to negative 30. So since x minus 3 whole square is a factor of f of x, similarly f of 3 would be equal to 0. In this particular case, we have 2, 3 square, the real value is this one. So plus 4, 3, and 30. Like p, the value of p is negative 30 with 3 and q equals to, in this form, we would find the value for q. Minus 90 plus q, and the value for q would be just bringing out the values over here, plus 36 plus 90, and value for q will be 72. This gives us both parts of question number 5. So that's it.